Assalamu alaikum. My name is Habiba and my ID is 014. Today I'm going to deliver presentation of organic chemistry. And topic of my presentation is short explanation of named reaction, which is basically Cannizzaro reaction. So in this presentation I'll discuss short introduction of the Cannizzaro reaction, its mechanism, and how was it named as a Canizarro reaction. And then I'll discuss some applications of the Canizzaro's reaction in industries. First of all, we see a short introduction of the Canizzaro's reaction. The Cannizzaro reaction, named after its discoverer Cannizzaro, is a chemical reaction that involves the base-induced disproportionation of two molecules of non-ionizable aldehyde to give a primary alcohol and a carboxylic acid. Like in this reaction, you can see disproportionation of two molecules is occurring. Disproportionation means basically a substance which is oxidized and which is reduced simultaneously. And when disproportionation occur in this reaction, two molecules are formed then. One is primary alcohol and the other is carboxylic acid. So how it was named as Canizzaro's reaction. Cannizzaro first accomplished this transformation in 1853 when he obtained benzyl alcohol and potassium benzoate from the treatment of benzaldehyde with potassium carbonate. But more typically, this reaction would be conducted with sodium hydroxide or potassium hydroxide, and the products will be sodium or potassium carboxylate salt of the carboxylic acid product. So equation of the typical reaction is this. When you can see two molecules of benzaldehyde are reacting with potassium hydroxide and the products are potassium benzoate and the other product is benzyl alcohol. So we see what is the nature of the reaction. The process is a redox reaction involving transfer of a hydride from one substrate molecule to the other. One aldehyde is oxidized to form the acid, the other is reduced to form the alcohol. Then I'll discuss what is the mechanism of this reaction. The reaction involves a nucleophilic acyl substitution on an aldehyde with a leaving group currently attacking another aldehyde in the second step. First, hydroxide attacks a carbonyl, and in the second step, the resulting tetrahedral intermediate then collapses and reforming the carbonyl and transferring hydride to attack another carbonyl. Then we see what happens in the final step in the mechanism of this reaction. In the final step of the reaction, the acid and alkoxide ions formed exchange a proton in the presence of a very high concentration of base. The aldehyde first forms a doubly charged anion from which a hydride ion is transferred to the second molecule of the aldehyde to form the carboxylate and alk oxide ions. Like in this reaction, you can see all of these reactions takes place, and subsequently the alk oxide ions, which is produced in this reaction, it acquires a proton from the solvent. So overall, the reaction follows third order kinetics. It is the second order in aldehyde and first order in the base. So rate is equal to rate constant of the benzaldehyde and rate constant of square of the rate constant of the benzaldehyde and the rate constant of the hydroxyl ion. At a very high base, a second pass becomes like which is reverse of the rate constant, and it will be then the rate will be equal to the rate constant and reverse of the rate constant. Then the pathway implicates a reaction between the doubly charged anion and the aldehyde. The direct transfer of the hydride ion is evident from the observation that the recovered alcohol doesn't contain any deuterium attached to the alpha carbon when the reaction is performed in the presence of the D2O. D2O is basically a chemical which is heavy water. So then we see what are its applications in the industry. Due to strongly alkaline reaction conditions, aldehydes that have alpha hydrogen atom instead undergo deprotonation there, leading to enolates and possible aldol reactions. Under ideal conditions, the reaction produces only 50% of the alcohol and the carboxylic acid. To avoid that low yields, it is more common to conduct the crossed Cannizzaro reaction, in which a sacrificial aldehyde is used in combination with a more valuable chemical. In this variation, the reductant is formaldehyde, which is oxidized to form sodium formate or to form the other aldehyde chemical, which is reduced to the alcohol. So in this scenario, we see each of two separate aldehydes can be converted completely to its corresponding product rather than losing 50% of a single reactant to each of two different products. Thus, the yield of the valuable chemical is high, although the atom economy is still low. So it is the reaction in which you can see both products which are formed are independent. So a solvent-free reaction has been reported in the applications of the Cannizzaro reaction, which is involving actually grinding of liquid to chlorobenzaldehyde in the presence of the potassium hydroxide, potassium hydroxide in a mortar and pestle. So these are the application, and this is the short explanation of the Cannizzaro reaction. So thank you.